pretty complicated timing. And you might wonder, how can I, compute this type of timing? So there's a lot of things going on. So but the idea here is that you don't have to compute timing by yourself. Everything is built into the SPA hardware. So everything is built into the hardware. The hardware will control the timing. You just need to tell the device what you want to do, and the hardware, the SPA, will do the timing for you. But generally speaking, how does the timing work? So again, you have this SS slave select line. So once you pull down a SS line, like SS1, then the SS1, you will initiate SPI transmission. The clock will start to run. It will go up and down, up and down. The clock runs. Then it's always at the rising edge of the clock. The data on MOSI and MISO are sampled. So data don't change on the rising edge. That's when you sample data on the wires. Then it's always at the falling edge. It's always at the falling edge. The data can be updated. So you can update, MOSI and MISO data, on the falling edges. So that's why we need a clock. We need a clock to synchronize our operation. So this is SPI mode 0. So there are different modes. There are 4 modes in total. So they can be configured by changing your clock polarity and your clock phase. So, this clock polarity 0, that means clock goes from low to high when SPI starts. It can also go from high to low when SPI starts. Then there are also 2 different clock phases. That means, do you want to sample data on the falling edge or rising edge? You have an option to configure that. So in total, you have 2 different clock priorities, 2 clock phases. So 2 times 2, that is 4. So there are 4 SPI modes that you can use. Then SPI is the communication channel. It's the telephone system. Then your BLE SoC and your sensor can talk on SPI, but you have to agree, what language you want to speak. You have to agree on the protocol. So the protocol is typically defined by your slave device or your sensor. So now we are talking to our BMI 160. So we have to define the language we speak. So this is defined in the defined by BMI 160 in the data sheet. So first, read. So we want to read the BMI 160 accelerometer. So let's say we want to read a register in this sensor. So how do we do it? So we have this MOSI, which means data goes out from the master. So the master has to first put a 1 on MOSI. That means I'm going to read. So if you put a 0 here, that means you are going to write. So the transmission starts with a read or write byte. So for read is 1. Then follow this read bit. You provide which register in the sensor you want to read. So it can be a data register. It can be a status register. Specify which register you want to talk to. Once the master is done transmitting the first byte, then the slave, the sensor, will respond. It's going to send you back the data in that register you are reading. So in summary, in SPI read, the master start with a read bit, then provide your register address. Then once the sensor gets that address, it's going to respond with the data in that register. That's the read operation. Then sometimes you want to write your sensor. You want to specify the sampling rate, or you want to specify the measurement range. You have to write. So to write, your master start with a 0. You put a 0 on MOSI, that means you are going to write. Then following that, you provide the register you are going to write. that's the, you specify the register address you're writing. Immediately following that, you go ahead to provide the data, the piece of data you are going to write to the register. So these are the protocols of SPI. When you talk to BMI 160, it can be different for a different sensor. But for the sensor we are using, these are the read and write sequences. So again, we'll be doing this in our lab 1. Our lab always consists of a pre-lab where you work on theoretical designs, then followed by a hands-on portion, which you do on Friday. So, make sure that you install all the apps. Is that a question?
Yeah, so the register, is that like a shift register within the actual sensor?
Yes. So in your actual sensor, there are many different registers.
Right.
Yeah.
Okay. Gotcha.
So make sure you install all the apps you need, including that sensor. So if you have trouble with that sensor, talk to our TA, he's right here. And take a look at the lab 1 handout. So lab 1 consists of pre-lab. So it's all about theory. It helps you understand